And the only thing that's different with example 6 is we need to isolate this absolute value before we split it up into two separate expressions. So all we have to do is throw that. Anything that's outside the inequality, use solving steps to get it to the other side. That gives us 4x plus 2 is greater than or equal to 5, which is equivalent to 4x plus 2 is greater than or equal to 5, or 4x plus 2 is less than or equal to negative 5. That leads us to two solutions. X is greater than or equal to 3/4, or X is less than or equal to negative 7/4. Fill in that because it includes an equal part, and then 4 goes into that. It looks like negative 1 and 3/4. And there we go. Last couple of examples, we're going to use absolute value notation to write an appropriate equation. All numbers whose distance from 8 is equal to 5/4. Okay, so distance means we're going to do some subtraction inside absolute value. So we want distance from 8 is equal to 5/4. So x minus 8 is equal to 5/4. So if it's a negative, that absolute value will make it positive. All we have to do is solve this inequality, and we'll solve it by writing the two equivalent. And I'll put that over here just so I have more room. X minus 8 equals 5/4, and x minus 8 equals negative 5/4. Okay, 4 times 8 is 32. And we get the two solutions. X is equal to 37/4, and x is equal to 27/4. See, use absolute notation to write an appropriate equation. Actually, this was my answer. This just shows that both of these numbers are exactly 8 away from positive 5/4 and negative 5/4. All right. Use absolute value notation to write an appropriate equation. All numbers whose distance from 5 is greater than 12.3. Same idea. X minus 5, absolute value. So if we subtract from 5, then we're going to get greater than 12.3. Now, I don't know if they want us to solve it, but I'm going to assume no, that we just have to write it. All right, I will see you in class for practice. Bring your notes.